Hello everybody, today I am back with another video, and today I'm going to be covering a topic which was actually recommended to me by a commenter on one of my videos. He recommended a video on maxima and minima, and that's what I'm going to be covering today. How to find maxima and minima, specifically if you're given the function f prime of x. So we're going to try to find the minima and maxima of f of x from the derivative. So let's get right into it. So we have this graph here. Let me just zoom out a little, and we got all of this. So it's a pretty big graph. I drew kind of big. Sorry for that. But maybe you guys can note this down really quick. Pause the video if you need to. And so what we're going to try to do, we're going to try to find the minima and maxima of f of x, as I mentioned earlier. So how are we going to do that? Well, first of all, we need to find something called critical points. And you might be asking yourself, what are critical points? Well, critical points are going to be points where the derivative is either 0 or where it's either going to be where it's 0 or infinity. So those are critical points. And we are going to try to note down what are critical points. And I said earlier, 0 and infinity. So where the derivative, we have the graph of the derivative, where it's 0 or infinity. So right here, we got one. The derivative right here is at y equals 0. So right here at x equals 3. So I'll just mark that down. X equals 3 is one of them. We also got x equals 6. X equals 6. We also got this one right here. I know this one might be a bit harder to tell. I got x equals 8. Now, we're just going to try to find out relative minima slash maxima. And we're going to try to find out how we can tell, how are we going to find out whether it's a minima or maxima. I'm going to explain that to you soon. So we got x equals 3 as 1. We got x equals 6 and x equals 8. So, first of all, we're going to try to find out what is x equals 3. Is it a relative minima, relative maxima, or nothing? Is it just a random critical point that's not really any of them? Okay, so we got x equals 3. Now, to find this out, we need to look at the graph as it approaches either side. We don't need to take a limit for this. I don't think you need to. You can actually just do it by looking at the graph. You'll notice that the graph here, it's positive. You'll notice that the derivative here as it comes, it's positive. Let's note that down. It's positive. Some people might even make a sign chart. And basically what that is, where's the derivative positive? You'll notice it's positive from x equals 1 to x equals 3. And it goes from negative to x equals 3 to x equals 6. So from here to here, it is negative. I'll erase this little dot here. And we got from here, we're going to get that it is positive as well. And right here, it is still positive as it goes to the... I am so inconsistent. So we're going to get positive. We're going to get positive. So we got a bunch of positive areas, and we got negative areas. And how we basically differentiate, like how we basically find out the different regions, basically we just look at the critical points, and we look in the regions between critical points. And that's how we use a sign chart. A sign chart looks much better than what I drew here, and we actually don't need this. It looks much better than what I drew here. I'd recommend you'd ask your teacher or your counselor on how to do a sign chart. If you do want me to make a sign chart video, I will do it if you guys leave a comment down below. Okay. So, what are we going to do with this? Sign chart doesn't tell you much right off the bat, but it can tell you a few things. So, we're going to check that this goes from positive to negative, and as we said, this is called a critical point. Critical usually means it's changing, or it's 0, or something's going on there. That's what a critical point means. So we got the point right here, it goes from positive to negative. The derivative goes from positive to negative. Now, a relative minima and a relative maxima, what they basically look like, and I'll actually go to this end of the graph right here. Well, actually, I got some space right here. So a relative minima will look kind of like this. It won't always be curvy. It might be a bit straight, a bit more straight, whatever. But generally, they look kind of like this. And then, obviously, the graph will just go off in some way here. Basically, it is the lowest point in this, like, region. And what we can do is, let's say, well, this is obviously going to be the minima. And what we notice here is that the derivative here, if we look at the sort of, I know it's kind of hard to tell, but as you notice that the slopes here are increasing, are negative, but they're getting smaller in value. Like this slope right here might be -2. We might get -1 right here. We might get -0.5. You'll notice that they're getting bigger as a negative, but their absolute value of the derivative is getting smaller. You'll notice that it's getting closer and closer to 0. And as it comes here, this is when it turns to positive. You might get positive 0.5, you might get 1, you might get 2, and so you'll notice a similar pattern there. And so when you do it, it goes from, it's important to note that x is increasing that way, that as this happens, we see that it goes from negative to positive. So we look for where the derivative is going from negative to positive. Do we see that here? We actually don't see that here. We see it go from positive to negative. That's the opposite. But however, we do see it go from here to this region right here. So we can actually say with confidence that x equals 6 is a relative minima. Not a maxima. Relative, we're going to say relative min. Now I'll just abbreviate it for now. So we got that, and I'm going to get my eraser right now, and I'm going to show you what the maxima looks like. And it's actually pretty similar, just kind of in reverse. And maximas look like this. If you remember the minima video, I'm pretty much just flipping that. And you'll notice that, again, x is increasing that way. And so we got the slopes here, and it'll be 0 right here. The slope will be 0 right here, just like the critical points. The critical points have a slope x equals 0. That's why they're called critical points. And you can notice that the slope is really big here. The absolute value of the slope is going to be really big here, here and here. But you'll notice that the slopes here are negative. The slopes here are positive. Similar to how we saw in the minima, except now it's in reverse. So that means that we got positive, we got negative. This is a relative I'll just write relative maxima. That's what I meant to say. So we're going to go right here, but we still got this point right here. Now this is an anomaly because you'll notice that this one changed signs, plus to minus here. That's a relative maxima. This one went minus to plus. That's a relative minima. But what about this? This goes from positive. We got a positive region on our sign chart and another positive. So it goes from positive to positive. This one we actually can't say anything about. We cannot really determine this. So this is like neither. It's a critical point still. It doesn't take away that status of being a critical point. But it's not a maxima, or not a relative minima, or a relative maxima. That is one thing that is important to note. So what would maybe this look like on the graph of f of x? F of x. Keep in mind, we've been working with f prime of x here, and we're trying to find out, is this a relative maxima, relative minima, all that. And so what would this point look like? Well, it might look like, kind of like this on f of x. If we were to draw f of x, at x equals 8, we might notice this sort of thing. You'll notice that the slope eventually does come to 0 here. It will actually become 0 right here, but the slope is still positive everywhere. you'll notice that right here, this about here, the slope will be 0. So f prime of x will be 0, just like we noticed in the critical point. Will be 0, or f prime of 8, that would be more accurate. This is f of 8, the region around f of 8. And so you'll notice that here and here that the slopes are positive, and the slopes continue to be positive in both areas, just like we noticed on the sine chart. And let's say if we're going from negative to negative, then we might just see it in reverse. And you'll notice that slopes are negative, and this is where it'll actually reach. It'll look flatter like this, but it actually does. I know my drawing isn't the best, but it actually does end up reaching a derivative of x equals of f prime of x is equal to 0. Sorry for my bad handwriting, but hopefully you got the gist on that. I hope this video did help you guys understand what maxima and minima are. I'm running out of breath, and thank you guys so much for watching.